Hello friends, so welcome in the new video. So this is the visual of last video. So in last video we have seen that how to interface TDS sensor via ADC with STM32, and here in the screen you can see we have the ADC value with voltage and TDS value as well. The main core part of this code is to convert the input voltage into equivalent TDS value, and that value display on UART. Okay, so this was the last video. Now here we have some problem, right? So the problem is like here, to get the value of TDS we must have laptop, right? Because ultimately we have used UART to send the data, so definitely laptop is required, or any other medium on which we can send the UART data, right? But for that, today I come up with a new video, and I'm just adding one more module called LCD. So LCD we have already covered in my previous one or two videos. So basically LCD will provide this solution, because to display any sensor value we have this solution called LCD. It is very simple, very cheap, because it's around 200 to 250 Indian rupees is available in the market. So you can purchase it, okay, and you can use it. So you can see basically we are just removing this UART part and we are simply adding this LCD. So the benefit is no laptop is needed, fully portable, clean design, and here you can use this to measure TDS value in your kitchen, in your room, in your what we can say pond nearby your house, or anywhere, any remote place also. So basically you have to use simply power bank, power your board, and on LCD display you can see the value of the TDS. So this is what we are going to achieve this. And here one advantage is, with RTC, with ADC, with UART, we are adding one more module called LCD. Right now, what is LCD? 16 cross LCD. I will add the link in the description. So I have covered this module in very basic way, starting from what is LCD to each pin description, and then I wrote also one code. So here in description you can see that video. Also I have covered in one of the video I2C LCD. So here in this on the screen you can see it's called 60 cross 2 LCD display. So here total 60 characters are there and 2 lines are there. So totally 32 character you can display over here, right? 16 column, 2 rows. Now it can display 32 character total. Here in our demo I'm using blue backlight LED, right, and white text, and the pixel size is 5 cross 8, and cost is very cheap, 150 to 200 or even 250. And here on LCD we have standard HD 44780 controller is there. So some commands are there, and basically by simply sending those commands LCD can be configured. So what should be the starting character, on which line I want to display, right? I want to clear the LCD, I want to rotate the message, I want to left shift, right shift, everything you can do using those LCD commands. And for that we have this LCD controller is there. And to know more about this, please watch the video given in the description. I have covered everything from basic to complex level, right? So now the problem is too many wires, right? Because this 16 cross LCD is having 8 data channel. Here you can see 8 data channel for control channel, and we have to use 16 wire, right? It's a very messy type of architecture, right? You have to use 16 GPIO, difficult to wire, debug, and also if you have limited ports available, so this simply this only module will cover more than 16 to 18 wires, right? And to remove this, what we are currently doing in this demo, so I'm using I2C based LCD. So here you can see this is the structure, and in demo also I will show you that I2C based LCD. So is this type of LCD is having small chip connected with this. So that chip will convert this 16 pin into 4 wire output. 4 wire output is simply we have VCC, ground, SDA, and SCL. So I2C is required only 2 wire SDA and SCL. So it's a 2 wire communication. You can use multiple device on same bus. These are the advantage of I2C. Each device has unique address. So for our LCD, we have this 0 cross 27 address is there, right? Which is very means popular address for this type of device LCD. So if you don't know the address, please try this address, and definitely if this address is not work, then you have to check the data set, right? Now here one device will be master. So in this demo our STM32 is a master controller, and LCD or any other sensor will be slave. So in this demo again LCD will be slave device, right? And now to understand the I2C in very simple way, you can consider this architecture, right? Here one bus multiple device, so you can see I2C bus architecture, right? So in here you can see one master is there, right, and multiple devices are there, each having its own address, and 2 wires are there, one is SDA, one is SCL, one is clock, and one is data. Now to understand this, you can understand this analogy called city bus. So here one route is fixed, right? Only 2 roads are there, one for clock and one for data, right? Multiple stops are there. So each device is, you can consider as one stop. Each stop has a number. So number means ID, right? And bus call stop number. So whenever I have some data, I will simply call stop number or simply address. So only that device will receive that particular data, right? Another will wait silently. So passenger board there, where the stop number is there or the where address is given, and other passenger will simply wait with in silent mode, silently, right? So this is what the overall structure. So I2C is having two wires, multiple devices can be connected, each has its own address, master call address, device respond, and other ignore the signal. So this is the overall architecture, and this is very simple. So by simply using I2C based LCD instead of normal LCD, we can save many wires, many GPIOs, and our design become very simple. I will show you this in demo. So without wasting time, let us start modifying our code. So this was the same code which I have uh, demonstrated you in my last video, right? Now as I told you earlier, I'm just copying this code somewhere, right? Because I'm going to use this code in future. So I'm just copying this. Why I'm copying? Because now ultimately I have to change this IOC file, right? Because this IOC file is having RTC enable, ADC enable, UART enable, but now I have to enable I2C. So simply let us select I2C2 and select this, and here you can see two wires will be there. One is PF0 is called SDA and PF1 is called SCL, right? And with this you can see we have this standard frequency, standard mode, I2C frequency is 100. So I'm not changing anything. I'm simply enabling this and generate the code, regenerate the code. And when you regenerate the code, your other part will remain same, but your parts inside the main function will change, right? So that's why I'm copying that code. So without rewriting the whole code, you can see other part will remain same, but only while one part or main part will totally overwrite, right? So here in main part, you can see in our code void main, we have nothing, right? So now I'm simply copying this from here, because what I need is our previous while one part, right? From here, from RTC to this whole code as it is, right? So I'm just putting it over here, right? I'm again releasing the and generating hex file. Now, so here this is what the our previous code is. Now here I will add our LCD part. So for that, I will give this code in the description. I have also discussed same code in my one of the previous video. So I will not explain you that code in more detail, but I will tell you how to reuse that code. So here you can see this is the GitHub profile, right? This code is already shared with you. So I'm simply copying this old code as it is, right? Up to here, because this is the address part, right? And this is the LCD command function, this is LCD data function, and this is initialization part. So here initialization part is having this 28, 08, 101, 06, 0C, all these different commands are there. And our LCD's microcontroller will respond for this command. So basically we are simply writing different commands. So how to reuse it, simply copy all the functions up to here and put outside of the main program anywhere. Then we have this LCD address. So put it in starting of your program here, right? And finally, we have the main function. So let us simply copy this and use it in our main program. This is the main code, okay? And copy it over here. So this will simply display hello on my LCD. So here LCD initialization part is there, right? And one minute, let us put this init part outside of the main function, because this is single time requirement. So LCD initialize init function will initialize the LCD, and then LCD command will write the data, means it will set the position and it will write the data. Now, meanwhile, our LCD is also connected with the hardware. So after explaining this code, I will demonstrate you this how our connections are actually there, right? And yes, so this is what the basic code. So if I will run this, I can simply send hello message on LCD. So once we run this, you can see this message is there on LCD. Okay. Now again, here also I would like to change something, because we have this I2C 2, right? If I'm not wrong, yes, we have this I2C 2. But in this code, I have used I2C 1. So I have to simply change this. Okay. So let us reopen this code. Check where I just copied that function right here, and here I have to change this from I2C1 to I2C2, right? And what this function will do basically in this whole part, you can see in LCD command also we have some command. That command will first mask upper 4 bit, okay, then it will mask lower 4 bit, it will shift left 4 times, right, and then it will simply write that on this function, right, provided we have this facility, this configuration, you can say enable 1 to enable 0, right. This is what we are doing because this is what the architecture of LCD. So again, I'm telling you that I'm not here discussing detailed architecture of LCD, how LCD works. And if you want to know, please watch the video in the description. But this is what function is all about. So basically, when you send the command, you have to make sure that your RS should be 0. And after each command, you have to generate enable high to low, and then that command will configure the LCD as per your requirement, right? And we have I2C, so simply I'm using this command as it is. I'm using this function as it is, and here in argument I'm passing LCD's command, whatever command we are. Sorry, this is the address of the LCD, and this is the command. So here we are creating, we are making one command, and we are sending that command on I2C. And since we are passing the address, so it will definitely writing in our LCD only, right? And this is simple timeout function. Same way here also data, in data also you can see same function we are using. The only different part is RS is equal to 1, right? So this is again LCD's internal requirement, internal microcontrollers programming. So when RS is 1, it will consider that message as a data, and when RS is 0, it will consider that message as a command. So now this is what total thing. Now here some commands are there. So this 28 is actually we are telling that my LCD is 4 bit 2 line, right? 08 means we are setting display off. When I pass 01, it means clear the display. So it will clear the display on the screen, right? Then this 06 command is there, so it's entry mode. So it will simply set increment the cursor, right? So here many different commands are there. You can go and search on internet LCD commands, and you will see plenty of commands, right? So you can send them as per your requirement. Since this is very basic demo, so I'm just setting my LCD in 4-bit mode, clear the screen, turn on the display, move on line 1, right, and then start displaying message. And this is what the LCD string. So simply using this function, I can pass the string also. Internally it will manage and it will display the data on the function, right? So here it will check the message character by character, and that's why you can see to send the message I'm using LCD string, right? So now let us write this main function, because ultimately what we want is to display this TDS value on LCD, right? So let us use this string first of all, and outside of this while one, I'm simply writing 80, and here I'm writing TDS, and then another. Now let me explain this also. So LCD command 80 means 80 will tell that my LCD first line. 80 means first line, C0 means second line. 80 means first line first character, C0 means first line first character, right? So here I'm writing 80 means this TDS will display on first line, and C0 means this monitor will display on second line. Okay, monitor. And now let's add some delay. So this message will print on LCD and it will wait for around 3 seconds, right? And then it will execute next function. Now after this, let us clear the LCD, because after this we want to display the TDS value also. So to clear the LCD, we have 01, right? So you have to write 01 command, sorry. So it will clear the LCD. Okay. So now LCD will have nothing on the screen, right? And let us wait for very small time period 2, right? And now we have this function check time 1, check time 2. So after 2 seconds, it will execute this function continuously, right? And since we have the TDS value available with us, where is the TDS value? This is the TDS is the TDS value. So now I want to send this on my LCD. So again, I'm using LCD command function, because once we have LCD monitor display, again I have to display something on LCD. So let us write 80. So 80 means first line 80, right? And here let us take one character, line 1, length of 20, you can say, right? Now I'm loading my message on line 1 character, and message would be, sorry, something Now let us turn on the numlock. TDS, and it will be percentage T ppm is our value, right? And our data is TDS int, right? This is what the TDS value is. Okay, and simply now I have this message in my string, so I just use this LCD string function and to send this on LCD, right? So what I'm doing, I'm simply writing this TDS and my TDS value extracted from the sensor, and just I'm copying this message into line 1, and then I'm passing this message on first line, right? Now let us, we have TDS value on first line. Now let us write water quality on second line. Okay, so I'm just copying this again. I'll show you how to reuse the code, right? That's why I'm just copying my old function. So instead of rewriting, you can directly reuse them, right? So LCD scan command C0 means now it will be second line. Okay, and here also I'm just creating one character, line 2. Okay, size is around 20. Okay, and now if, now let us put condition, if TDS integer is less than 300, right? So if my TDS value is less than 300, we can say water quality is good, right? So set print f. So let us copy this message on line 2. Quality is excellent. Okay, only this message, quality is excellent. Let us copy this message. If my TDS value is 300, less than 300, okay, then again let us write a next function, else if my TDS value is less than 600, means more than 300 and less than 300, then copy another message, but this time our message would be not excellent, but we can say it's good, right? It's good condition, not excellent but acceptable. Again, these are not standard parameter, I'm just writing this for the demonstration. Okay, but just let us consider 600 is good, not excellent, and if TDS value is less than 900, we can say quality is fair, and above this worst, right? So for now let us consider this fair, and else quality is poor, right? Out of 900 means greater than 900, quality is totally poor. So I have 4 different conditions. If this condition is satisfied, this message will copy in line 2. If this condition is satisfied, this message will copy in line 2, and ultimately I have to simply send the message. So after checking all, let us simply send the message on LCD, right? So this is what the total program is. Let us release this target. Oh, lots of errors are there. Check what is the issue. Oh, sorry, I just forgot this. Again here, what is missing? I think one extra bracket is there, right? Okay, this is here I have to use semicolon. That's it, right? So this is what total program is. Now let me show you the design, or let me show you the connections. So here you can see this is the board, this is the sensor, and this is the LCD. You can see LCD is connected with this board using only 4 wire. This is supply volt plus 5-volt ground, and these 2 wires are for SCL and SDA. Here you can see this is the LCD. LCD is having this small chip which convert this 16 pin into I2C, right? And here is the LCD. Now as we have this code, so I'm simply uploading this code on my board. You can see, right? And here let us observe this LCD. Now let us reset this. What is happening? Let me simply power off and power on this. Here you can see now I'm pressing reset TDS monitor. This is the message. And after 3 seconds, here you can see the quality of TDS. Quality is excellent. So this message length is large. So we can have only 16 characters. So that's why it is not displaying totally. But here you can see TDS value. This is the water. This is RO's water. So that's why you can see TDS quality is excellent. So before that, some garbage value is there. So simply you can power off and again power on the LCD, and that garbage will remove. And if not, then you can simply multiple time press reset. So this is common for this type of LCD display. And uh, to resolve such issue, you have to write such firmware. So before writing anything, it will totally reset the LCD, and then it will write something on this message, right? So here you can see this is how after each 2-second interval value is changing, but it is within the limit because I have used average 30 time. I'm just reading the sensor and then averaging it. So this is what for today's video. So here you can see overall setup. So this is how simply providing power to this board using power bank. Also, you can have standalone setup. So you can simply put it anywhere, any remote place, and you can measure this value. And this demonstration is combining 4 different modules called RTC, ADC, UART, and LCD. I2C basically I2C, but again one external hardware is also there. It's called LCD. So this is what for today's video. If you like my work, then please like my YouTube video, subscribe my channel, share it with your friend, and till then, bye bye. Thanks a lot.